Hi students, this is Mr. Yang. Today we are going to talk about 5.6, where we will first learn how to convert between radians and degrees. Then we will learn something called angles in a Cartesian plane. There's quite a bit of definition, quite a lot of new concepts in this whole lesson, so please bear with me. And let's start with the prior knowledge. We have all seen pi already. We have worked with circles before, but what is pi? It's not like people actually found pi first and then they defined a circle using pi. Actually, it's quite the opposite, quite the backwards. Let's say this is our circle. I can choose to, let's say I'm going to cut my circle like right here, and I'm going to drop all the whole thing as a string. And then here's my radius, because that's how circle is defined. You have a set point and you have a set length, which is actually the radius, and you just kind of drag it all around this certain point, and that's going to form a circle. So pi actually is related to how long this little string is compared to the radius. So pi is defined as the ratio of a circle's circumference to its diameter. Diameter is just 2r, twice of the radius. So it is about the radius, or you can think it as about the diameter. Either way, how many of the radii are there in the whole circle? That's how pi is actually defined. People actually found a circle shape first, and then they tried to figure out, wait, how long is this whole thing all around? And they found the number they call pi, which comes next. Circumference of a circle, c equals 2 pi r. And again, the pi comes right here. Circumference over the diameter, or circumference over twice of the radius. That's circumference of a circle, c equals 2 pi r. Today's lesson is going to be related to that, because here's the thing. We already know inside a full circle we have 360 degrees all around. But that's not actually the most direct way to define something. If I ask you to imagine 360 degrees inside a circle, ever since the first time you learned about circle, it's kind of hard to imagine. How would I know that's 360, right? How is that defined? So at first, people didn't define circle using degrees. People actually define circle using a radius. And that is related to today's concept, which is called radian. Radian, well, like you can see, is kind of related to the word radius. Radian is another unit of measure for angles. Just like inches and centimeters are for length, or we have feet or yard, whatever, all of these are just units. Radian is another unit compared to degree. And radian is based on the radius of a circle. Here's how that works. 1 radian is the measure of the central angle whose arc length is the same as the radius of the circle. Central angle is referring to this angle right here. We have a center, and this angle that's based on the center, that's called the central angle. This angle is facing an arc. This is the arc that the angle is facing. It's saying when that arc length is the same as the radius. So you can see this part is r, is the radius. It's the same length as the actual radius. When they are the same, this angle in the middle is 1 radian. Let me actually write it here. That angle is actually 1 radian. Based on the circumference formula, we have c equals 2 pi r. So basic question is, how many r is there in the whole circumference? There are 2 pi amount of radii, which in other words, the angle of a circle in radian is going to be 2 pi. So in other words, let me draw that out. I extend the radius to a full length, full diameter. This is 1 radian. I can have another radian like here, and then another radian right here, and then we have this little extra right there. And that basically means you have 1, 2, 3 radian and a little bit extra. That's where it's actually pi. It's 3.14. This little extra is 0.14, around 0.14 of a radian. So that's the definition of radian, which is quite new. It's different from any angle we have learned before. But you just gotta keep in mind, this word is related to radius, and that's why it's basically counting how long is this, and trying to use radius to measure how long that is. So here's a few important points. 360 degrees is corresponding with 2 pi in radian. So 360 degrees equals 2 pi radian. And if that's the case, 360 equals 2 pi radian, I can divide both sides by a 2 pi. That will give me the right side as 1 radian, and the left side would give me 57.30 degrees. So 1 radian is around 57.30 degrees. Next, how many degrees in the side of my circle? The side of my circle is like half of the circle. So it's half of 360, which is 180 degrees. And the last question, how many radians is in a semicircle? If 360 for a full circle is 2 pi, then half of that is got to be pi. So 180 degrees correspond with pi radians, which means we can have a conversion formula right here. When you try to change from degree to radian, it's going to be pi times multiplied by pi over 180 degrees. If you're trying to change from radian to degree, it's going to be multiplied by 180 degrees to pi over pi. Here's something that could help you. When you try to get a degree as an answer, you need your final answer to actually have a degree. That's why the degree is on the top. But if you're trying to get a radian, then you're trying to get rid of the degree, then the degree symbol needs to be on the bottom. For example, let's say 30 degree times pi over 180 degree. You can see the degree symbol will also, the degree symbol will also cancel. You don't have this degree symbol anymore. They would, they would actually cancel. That's how you change it into a radian. So basically, in other words, if you see a number that doesn't have a degree symbol, it's just a number, that's got to be in radian, because the degree would need to have the degree symbol. Okay, now that's the new definition. And next, let's actually work on the formulas with some examples. Convert the following angles to radian or degree, depending on which is given. This is clearly 0 degree, so multiply by. Remember, if we want to try to get rid of the degree, we're going to put degree on the bottom so they can cancel. How is pi? 0 pi over 180 is just 0 radian. That is number 1. Number 2, I'm going to multiply that. Again, I'm trying to get rid of the degree, so degree goes on the bottom. How is just a pi? That's going to give me 30 pi. Don't forget degree symbol over 180 degree. The degree cancels. 30 and 180 simplifies to be 1 over 6. So it's 1 pi over 6, or it could just be pi over 6. You can also write it as 1 over 6 with a pi on the side. The pi kind of works the same as a variable. Next, number 3. Multiply by pi over 180 degrees. For this one, I'm actually going to use something called cross cancel. You can still choose to multiply across, but some of you might find out that you have bigger numbers. So if you're actually trying to make this process a bit faster, get some smaller numbers, you can do cross cancel. The degree symbol is gone. 60 on 180, 60 over 1 would be 1 over 3. So final answer, pi over 3. That is in radian. And that is in radians as well. Okay, negative 10 degree, so multiply by pi over 180 degree. Degree symbol is gone. 10 on 180, that's 1 and 18. So we have negative pi over 18. Next, multiply by pi over 180 degree. Degree symbol is gone. Divide everything by 20. That's 7 and 9. So negative 7 pi over 9. That is number 5. Number 6 times 180 degree on the bottom, pi on the top. Degree symbol cancels. And you see for this one, if you want to put it together, that's 305 over 180. Well, you kind of simplify the same way. Divide everything by a 5. 305 divided by 5 is 61. 180 divided by 5 is 36. So negative 61 pi over 36. That is number 6. Next, number 7. This time you see you are given the pi. And you don't see any degree symbol. That means that we are changing from radian to degree. So that means we actually want the final answer to have a degree symbol. That's why we gotta put it on the top of the fraction, and pi is on the bottom. Pi is canceling, and then you have 360 degree over 3, which simplifies to be 120 degree. Next, multiply by 180 degree over pi. Pi is gone. 8 on 180, you can choose to do it Altogether, put the 8 on the bottom, 9 times 180, that is going to give you 1620 degree on the top. Then simplify it, that works. Or you can choose to cross cancel. That could divide by 4, that's a 2. That's a 45 degree. Final answer is going to be 405 degree over 2 degree. Or that could just be 202.5 degree. That is number 8. Number 8. The next one should actually be number 9. But here it is. Since you don't see a degree symbol, we're trying to change into degree. Pi is gone. 6 on 180 becomes 130 degree. So finally is negative 11 times 30, negative 330 degree. Some of you might be wondering, wait, how do you have a negative angle? That doesn't work. Well, we will talk about that next, after these practice. So number 9, multiply by 180 degree over pi. The pi is gone. Now 180 become 120. So that is going to be 100 degree. Number 11 times 180 degree on the top, pi on the bottom. That is gone. 18 on 180 becomes 110 degree. That together is 310 degree. Next, 90 degree symbol. That means we're not trying to keep a degree. So I need to make the degree gone. I need to cancel it. So I'm going to need to put 180 degree on the bottom, pi on the top. Degree symbol is gone. 90 over 1, and 90 on 180 is 1 and 2. So finally, we just have pi over 2, or you can write it as 1/2 pi. That is number 12. Number 13 through 21. So 13, well, this is a tricky one. You don't see a pi, okay, but you also don't see a degree symbol. That's actually more important, because a degree symbol has to always be there to indicate is a degree. We don't see that. That means this is radian. So we are going to multiply this by 180 degree over pi. So now I can just do 3.1 over 1. Type in my calculator, that's 558 over pi degrees. And that can simplify to be 177.62 degrees. 14, since we have radian, changing into degree. Pi is gone, 4, that's 45 degrees. So together, that is going to be 405 degrees. Number 15, this time changing from degree. So degree is on the bottom, pi is on the top. And I can divide everything by a 5. That's going to give me a 36 on the bottom. That divided by a 5 is going to be a 187 degree. So finally, I have, well, not degree, actually, the degree symbol is gone. So 187 over 36, negative sign in the front, times the pi. I'm going to give you some time to work on 16 through 21, and I'm going to quietly work on my end so you can check your answers when you are done. Okay, so these are the answers for 16 through 21. When you are done, you can have a look, but they're all the same. It's just more practice. So now let's move on to the next next concept, which is called angles in the Cartesian plane. When you're working the previous questions, you can see the angles could be negative and could also be way bigger than 360. And that's because when we deal with angles in the Cartesian plane, we can have any kind of angle that we want. So you see this angle right here, but what if I turn it a bit more? I turn it another 360 degrees. What if that's the case? That's clearly more than 360. That's kind of how angles work in the Cartesian plane. You can turn it as many times as you can, and that's just adding on to 360 degrees. But since we can't just start the angle anywhere we want, we are going to need to have something called a standard position. The vertex of the angle is on the origin, right here. The angle is measured counterclockwise from the positive x direction. Positive x direction, so that's got to be the side. And then we are rotating counterclockwise to find out the actual angle. So initial side. Initial side is a ray that starts from the origin and goes to the positive x direction. So this is the initial side. That means whenever we want to make an angle, make an angle in the Cartesian plane, we always need to start from that position. Next, terminal side. Terminal side is the ray that makes the angle when its initial side is in standard position, or where the angle stops. So in this case, as you can see, my angle stopped right here. This is the rotation. Oh, it stops right there. So that is going to be my terminal side. These are some just new definitions. And let's have a look at more things. Coterminal angles. Angles that have a common terminal side in standard position. Standard position, again, they will always have the same initial side. That's guaranteed. We want them to have the same terminal side. Some of you might be like, wait, but this is like one set angle. How could you make another angle that shares that side? Here's how. Instead of stopping here, I can choose to keep going. I will go another full cycle and then stop right here. As you can see, my terminal side is the same side right here. And that is a coterminal angle of this given angle. Now you might be wondering, but how do I get a new angle? Well, the only extra part I did is right here. This part is already given, so the only extra part I did is right here. And if you look very carefully, you should be able to notice what angle is that. It's from the same position, goes a full cycle and comes back. That is actually 360. So all the terminal angles are related to 360 degrees. But we can't just work with any big number like we see, like 1,435 degrees, for example. We can't work with that. That's very hard to see, to visualize, and to work with. So we have something called reference angle. It is the smallest angle that you can make from the terminal side of an angle. So let's see, in this case, this is my terminal side. So from that terminal side, it's an angle with the x-axis, which it didn't say which direction of the x-axis. It just says the x-axis. So here's the x-axis. This would be my reference angle right there. The angle measure will always be less than, it could be equal to, but 90 degrees. Because as you can see, if you form an angle with the x-axis, there's no way you can go more. Like the highest you can go is right here, and that is 90. If you go the other side, that's your reference angle. It's always the terminal side forming an angle with the x-axis. That is called a reference angle. Now let's have a look at coterminal angle examples first. Find a positive and negative coterminal angle first. Then in terms of n. We are given 70 degrees first. And again, if you want to find a coterminal angle, they need to have that same stopping line, stopping rate. That's why we're always just going to go more 360 degrees or 360 degrees less. Either way. For this, I'm going to do positive and negative. A positive, I can just add 360. That still remain positive. That's going to give me 430. But for the negative, I do need to actually subtract 360. That is going to give me negative 290 degrees. As for in terms of n, as you can see, these numbers are all related to 360 degrees. I can add another 360 degrees, for example. That just means I'm adding two 360 degrees. Or I can subtract a bunch of 360 degrees. That's why if we want to represent all the angles in terms of n, all the coterminal angles, just going to be the original angle plus 360 n. And the n could be anything, positive number, negative number, anything. That is how we represent all the coterminal angles. Next, let's do B. Positive is negative 225 plus 360. That is going to be 135 degrees. As for the negative, negative 250 minus 360, and that is going to give me negative 600, well, not 600, 585. Rewrite that. 585 degrees. Then negative 225 degrees plus 360. That's how it works. Next, 135. So positive 135 plus 360. That's going to give you 495. Or negative is 135 minus 360 degrees. That is going to give us negative 400. Oh, it's not negative 400. It's actually negative 225 degrees. So 135 degrees plus 360. The example, well, part D, positive. That adds 360 is going to give you 240 degrees. That subtract 360. That is going to give you negative 480 degrees. And these are coterminal angles. Negative 120 plus 360 n. Lastly, we're going to go from our definition of reference angle, find the angle measurements, and the reference angles. So here they are. If it's in quadrant 1, is actually the easiest one. Quadrant 1. 60 degree. Well, first this is my initial side. This is my terminal side. My 60 degree is right here. That happens to be the reference angle as well, because this angle is forming a small angle with the x-axis. Next, number 2, 135. You don't quite know how to tell where they should be. Well, this is 0 degree, and that's 90 degree, that's 180 degree, that's 270 degrees. So clearly you can see where 135 should be. It's between 90 and 180. It's around here. That's my initial side. I have a terminal side. This is the actual angle and of 135 degrees. The reason I keep drawing that is because I can totally draw the other way. Then my arrow is pointing backwards. I should have a negative angle. So I can draw these to indicate exactly where my angle is and how big they are and which direction they're turning. Now, this side, this terminal side is right here. It's forming an angle with the x-axis. So if you were like, how do I find that? Well, if you don't remember, a straight line right here is 180 degrees. So you're basically doing 180 degrees minus 135 degrees. That's going to give you a 45 degree right there. That's example 2. Example 3, 210 degrees. That is clearly between 180 and 270, slightly over 180, so it's around here. This is the actual angle. Now, I need reference angle. This is the terminal side forming with the x-axis. That is 210 minus 180, which is 30 degrees. Number 4, 150. That's between 90 and 180. So it's around here. And this is the actual angle that we are using. And clearly, we can find out the reference angle with the x-axis is right there. 180 minus 135 is 25. Well, not 25 actually. It's 45 degrees. Okay. More. Number 5, 270. This is 90, this is 180, this is 270. So it's going to be down here, 270, and right here. So this is how it's going to be. That's 270 degrees. But when you try to find the reference angle in this case, well, it's forming same angles with the x-axis, so it doesn't quite matter. You can choose to use this side. That is 90 degrees as a reference angle. Next, number 6, you see negative sign. So clearly I'm not turning the counterclockwise because counterclockwise is positive. I'm going backwards. That's more than 360, so I'm going to go a full cycle and then slightly over, which is around here. And this, I already draw the angle. My reference angle is going to be still this side with the x-axis. That is 380 minus 360, which is 20 degrees. That is number 6. Number 7, negative 300 is between 270 and 360, but it's negative, so I'm going to need to turn the other way. Oh, not that color. I'm going to need to turn the other way right here. And then going negative, first let's get to 270. I need a bit more, so it's going to be around here. And that is the actual angle. So that means my reference angle is going to be down here with the x-axis. That is 360 minus 300, which is 60 degrees. And lastly, 225. That is between 180 and 270. So it's around here as the terminal side. This is my actual angle. And I'm trying to form an angle with the x-axis, which is right here. 225 minus 180 is 4. So that is, not 4. That's 45 degrees. So that is going to be 45 degrees. That is the these are all the examples for reference angle. It's a lot of concepts for today. If you have questions, please don't hesitate to ask. And that is everything for 5.6. Thank you.